Now. So hello, and welcome to the 14th live stream of me working on the Gunship game engine. Today's agenda is working on optimizations for the rendering system because I've been running into, almost immediately as soon as I started doing anything with the game engine, I started running into performance problems. So I'm going to be working on optimizing the rendering system by tweaking how I'm using OpenGL. I'm far from an OpenGL expert, but I have at least some idea on where I should start in order to improve performance. And this is kind of a very low level start, and then we're going to gradually go to more higher level algorithmic changes. But we'll see how much work is needed to kind of get me back under the performance threshold that I'm looking for. So here in my issue tracker, I've thrown together a couple of notes just about what I want to be working on first. What I'm currently working on, what I started on the last stream, was the minimizing the number of OpenGL state changes that I was making within my renderer. The way that OpenGL works is within the context, there is a ton of state. For example, if you want to even enable backface culling, you do GL enable server capability call face. And then once you call that, that's just turned on forever until you turn it back off. What I was doing was in here, every single time it would draw. So not just every frame, but once per every mesh drawn every frame. So in the current test that I'm running, if I can demo that, I would be enabling culling 16 times because I have 16 meshes in here, 16 times every frame. When really, I never disable culling, so I should enable it once at the start and then never disable it again, or never try to enable it again, because every time you tell OpenGL, hey, enable culling, it has to do a little bit of work that is probably more work than I have to do if I just know that I don't have to re-enable it. So what I've done is instead of calling raw OpenGL here within my draw code, I've changed it to talk to my own context wrapper. So that's handled here in this context variable. And I call enable server call and then pass it whether I want it to be enabled or not. And then this keeps track of whether or not it's been enabled. So if we take a look at the context object, it's got variables tracking various bits of context state that I care about. In this case, server calling. By default, server calling is disabled because that's how OpenGL has it. And then when we do enable it, we check, have we already enabled it? If not, or basically, if we're trying to set the state to something different than what it is, set it properly and then cache that value off. So effectively what we're doing is, on the CPU, we're caching off the OpenGL state that's being tracked on the GPU so that we have to do less GPU work as we change state around. We're making fewer state changes. I've started that work off so far with the polygon mode, setting the active program, and then culling. The last, there are a few more that I can work on, starting with the depth test, the blending function, and then things are going to get a little bit interesting with regards to the uniforms and potentially the textures that are set. Uniforms are interesting because there's an arbitrary number. They're effectively key value pairs with the keys being arbitrary strings. So keeping track of which ones are active and making sure to disable ones that the user doesn't want to be set is going to be a little bit tricky. But I want to try to make sure that I do this right while also make sure the behavior is correct while also optimizing performance. So I'll have to dig into how to do that in a reasonably optimized way. And that may mean changing the way that I handle uniforms. You'll notice in here that I haven't attempted to change the way that I'm handling vertex arrays. I'm still binding the vertex array object and binding the vertex buffer object along with potentially the index buffer. That's because the way that I initially built this, I kind of misunderstood the way that vertex array objects worked. And by misunderstood, I mean I didn't understand at all. I've looked into it. I think I have a little bit of better of an understanding of it. And so in order to improve the way that we're using vertex array objects, I'm going to have to change the abstraction that I've created. I'm going to have to add an abstraction for vertex array objects, which I will do after I finish up with these sort of easier fixes that I've got. So to kind of show where I stand now, let's run this example. So this is an example of my game engine running. The changes that I'm making aren't in the game engine itself. They are, this is an example built on top of the game engine, basically the exact same way that you'd build a game. The game engine is in turn using my OpenGL renderer, which is in turn using this GLUtil library. I can open up my libraries list. This GLUtil library, which is used by Polygon, which is the renderer, which is in turn used by the engine proper, which is Gunship. So compilation is a bit slow. Every time I make a change, it's got to compile like 3 layers of crates. But it's much easier for me to build the example within the engine rather than building it on top of like raw OpenGL or even on top of the renderer directly. It also gives me a kind of a higher level picture of what's going on. As things slow, as the renderer gets faster, we'll get to see what other parts of the engine are potentially bottlenecks once we remove the renderer as a bottleneck. So if we, if we close this, we can kind of take a look and get a rough idea of how long it's taking. So with the screen recorder running, it's taking me, roughly 40 some milliseconds, 41, 44 milliseconds, 51 milliseconds per frame, 44 milliseconds per frame. And we can take a look at what the render is. The render itself is most of the work. So, render is 44 milliseconds, 56 milliseconds, 57 milliseconds, 56 milliseconds. Jesus, man, that's 53 milliseconds. Yeah, really long time. It's like 29 milliseconds when I don't have when I have my computer plugged in and when I don't have the screen recorder running. So the screen recorder is slowing things down, but the effect should be the same. If I speed things up in my code, we should see those times go down, even if they're longer than they would necessarily be in an actual gameplay setting. So I'm gonna go ahead and continue with this work, starting with the depth test. The user code can call. Let's take a look. Then call depth test and set a depth test setting. And by default, there's no depth test, which I actually want to change. I want to make the default something that people actually want, which is having a depth test. But I'm not going to change the semantics now because I don't really want to break things. So what we want is, and this is something I wasn't kind of smart to do before, but GL disable server capability depth test. And now I want to change this so that, for example, like say we set a depth test, but the depth test that was set is exactly the same as what it was set to last time. We basically want to do nothing here. So I'm going to add a couple of variables to my context to keep track of what that state is. So we've got server depth test enabled will be a Boolean tracking whether or not I've even enabled depth testing. And then we need a depth function, which is an enum. And so we're going to do depth test, which will be comparison. Depth test comparison. We need to now add those variables here. So we want server depth test enabled. That's going to default to false because pretty much all of these server capabilities for OpenGL default to false. And then our depth test is actually going to be, I'm not really sure what that's going to be. So what we're going to do is, scrolling back down, we call GL depth func. So what we're going to do is we're going to go look that up. GL depth func. And that should tell us what the default value is. The initial value is GL less. So that's what we're going to set here. Comparison less than. Comparison less. Let's find out if that's real. It looks like it is, so that's what we want. And something I want to note is, here I'm specifying exactly what the comparison is, but in some of the other cases, I'm actually using the default value for these values. So, for polygon draw modes, we just use polygon mode default, and if I look that up, or here, since I've got winding orders selected, for the winding order to determine which face is a front face and which face is a back face, I use winding order default, and that's specified as counterclockwise by OpenGL. So that's what I've got in my winding order enum. The default value is counterclockwise. I'm okay with using the default value here for winding order because winding order is only really used in one place. It's only used to specify front face versus back face. But in the case of depth test, this comparison probably shouldn't have a default value unless everything within OpenGL that uses this comparison enum always uses the default value. And that may be the case. I would actually kind of expect that to be the case. But without knowing that, I don't want to give this a default value lest it be incorrect for some cases. So for now, I'm just going to say that I know that the depth test specifically uses comparison less as its default. So I'm going to use that. I'm going to use that explicitly here. And if later on I determine, comparison less is always the default value, then I'll switch that to being, default. But that is not the case right now. So now I want to add a couple of functions. We've got basically a function public, a create public function for enable server depth test, and we want a value for that. So we're going to do self enabled bool. We're going to do if enabled not equals self dot server depth test enabled, self dot server depth test enabled equals enabled. We'll cache off the value, and then we just have to do match enabled true false and we do the things that we're doing here. So in this case, we've got GL enable depth test or GL disable depth test. If I hit save, see if that compiles. It does, but it's unused. So what we want to do now is self.context.enable server depth test true, or GL or self.context.enable server depth test false. And then the next step is actually setting the depth function, which we only want to do if depth test is enabled at all. So we're going to keep track of that. We're going to do, we have depth test comparison, we have its default value, depth test comparison less, and we're just going to add another function that does pretty much exactly the same thing. So create function depth test, ref mute self, comparison. We do if comparison not equals self dot depth test equals comparison, and then we call GL depth func with our new comparison function, and that shall work. we should get a, oh, what is this? Oh, we forgot our unsafe. So now, we should just get a warning about it being unused. And we change this to call self.context.depth test with our depth test. And it looks like that compiled, so now let's run the test again, just to verify that everything is working correctly, although I don't believe the example I have set up will actually demonstrate the depth test at all, because I don't have anything behind anything else, so depth test shouldn't matter. But I'll at least be able to see if OpenGL starts spewing out a bunch of errors, which I don't want to have happen. That compile time wasn't atrocious, so it was probably longer than it needed to be. So looks like we're not seeing any like terrible spew from OpenGL, so maybe that's working correctly, who knows. It's honestly kind of hard to tell without just seeing something be broken. Shouldn't expect times to change all that much. Oh god, it went up. Honestly, this is like, looking at these times isn't terribly helpful because I'm not expecting this to like, each one of these to shave milliseconds off the frame time, because that's probably not the most expensive bit of OpenGL state change that I'm doing. Plus, these are pretty inconsistent. Like, this isn't really a good testing environment. Between all the other software I have running on my computer, including OBS doing the screen recording, this is going to yield pretty inaccurate results. I honestly don't really know what the best way to go about doing performance benchmarks for GPU-related stuff would even be. That's something I'm still going to have to do some research into. But at least looking at these gives me a rough idea of where things are. If I make some change and I see this drop to suddenly like 20 milliseconds or 10 milliseconds, like it makes some crazy drop, maybe that means that I did something right and I've really like heavily optimized things. I like flipped a switch, like the go fast switch, and now things are actually working right. Or maybe it means I broke something and now it's like only doing a fraction of the work it was doing before, and half of the scene's not rendering. It's mostly just something to keep an eye on. But so now what we can see is that for our 16 faces, previously for each one of these I was saying enable depth testing and then set the depth test to whatever that value is that's passed in. But it's enabled for all 16 of these meshes, and the depth test is the same for all these meshes. I'm pretty sure it's just less than. So now, instead, it's just enabled once. Pretty much the first time we draw, we enable depth testing. And since we never try to draw with it disabled, we never disable it. And then every time we draw, we basically just set the depth function the first time, and then it also pretty much never changes. And that's exactly the behavior we want. We basically do 2 OpenGL calls right at the beginning to enable depth testing and to set our depth test function, and then we never touch it again. And that saves a bunch of work that the GPU, either the OpenGL driver or the GPU driver, will have to do. Though, no telling how much actual CPU time that's saving us. Last easy one to do this for is our blend function. So we're going to just do this exactly the same way that I did the last one. We're going to add server blend enabled server capability blend. Yep. Bool, and we are going to blend func, which should be, see if we can find out what the type of those are. Source factor and dust factor. So oh, this is interesting. So I've got some maybe smartness in here where if I do source factor is 1 and dust factor is 0, that disables blending. In which case, and so that explains why I've got I've got this, where I've got blend is optional. If it's none, the kind of implicit thing that I'm missing here that is different is if it's none, we do GL disable server capability blend. Whereas if it's there, we enable server capability blend. And so that in the design of draw builder, I've got to collapse these functions down because they are real annoying. There we go. Instead of having a function on draw builder that says enable blend, disable blend, and then set the blend function, draw builder just kind of pretends that there's always blending enabled, and then if you want there to be no visible blending, you set the source factor to 1, the dest factor to 0, and then that has the visual effect of no blending, and then draw builder just kind of secretly disables blending in the background. In theory, disabling blending would speed up performance, but I, again, don't really know OpenGL all that well. I can't say what the most efficient way of disabling blending would be. I suppose that's actually something I could look up. So let's see if there's any quick answers. OpenGL disable blend versus source 1 dest 0. No, there doesn't seem to be like... I would expect that to kind of be just like an FAQ saying like, oh, note, instead of disabling blending, just change the source and dest factor so it effectively disables blending. I think what I'm going to do for the sake of simplicity is I'm going to always enable blending. And I'm just going to change the source and dest factor. So basically, I'm going to make my OpenGL work exactly the same way as my draw builder is pretending it works. So blending is just enabled. Server blend enabled is going to be true, even though that variable is now never going to be used. And we're going to get rid of this. And now what's going to happen is, instead of blending being optional, we're actually just going to make it a single thing. And it's going to use the same default values that that OpenGL uses. And that'll save me a smidge of trouble doing a bunch of checking every frame. I can just set the value if it's different. I don't have to bother enabling and disabling blending. And if that turns out to be the wrong thing to do performance-wise, it's not hard to change. So let's take a look at GL blend func. GL blend func. How long have you been broadcasting for this session? So let's see. Source factor, dest factor, and then there's also buff source factor, dest factor. I don't care about that. Source factor is by default 1, dest factor is by default 0. So by default, it effectively disables blending. Absolutely perfect. I can totally work with that. So we're going to take a look at blend. Change this to, well, let's see if we can go a little better with this. Source factor, is that in here? Yes, it is. Let's add a default. Impl default for source factor, function default. Source factor 1. And so, again, like I was saying before, if source factor is used in a bunch of different places with potentially a bunch of different default values, I don't want to set a default for source factor. I might want to split it into a bunch of different types where each type is only used in one place, and then that type can have its own default value. But I'm fairly sure that source factor is really just used in the one place. I mean, I'm searching for it right now to see where exactly it's used. Looks like... Oh, that's not right. So we would be looking at lib, and yeah, so far it looks like I'm only using it within GL blend func. So chances are it's only used in that one place, in which case it's safe to set the default value rather than using it literally here. So if we do source factor default, and then we want to do dest factor default. Oopsie, that's not right. And do the same thing here. Dest factor impl default for dest factor, and we're going to make that dest factor 1. No, 0. The opposite. Source factor. Let's make this a little bit more streamlined as well. Source factor 1, dest factor 0, and then this can now just use those default values. What is failing? GL blend func. Self dot, I believe that's blend. Right. I'm like spacing out. Yeah, self dot blend. So let's do criminy. All right, let's do it like this. Let source factor dest factor equals self dot blend, and then we can do this. That should compile, or at least compile better. Now this is broken, but that's fine because we no longer care about this case. We just do this. There's no longer sum. Now we're just always setting the blend to be whatever the user asks for. That's great. Give me a second. I gotta turn off the heater. I'm like melting. I had the heat on when I was just, walking around in my pajamas. Now I put clothes on and I'm warm. So that is now unchanged. And now the context needs to cache off the blend function. So blend is going to be source factor dest factor, and we're going to do exactly the same thing. We do blend source factor default dest factor default. Actually, I think I can just do default right there, right? Yes, I can, because that tuple can be default constructed. Which means I can actually go up here and simplify this a bit for myself. I can do default. And so I want to add a function to change it, so it checks the cache. So pub create function blend refmute self, and we're going to do source factor dest factor, and we're going to do if source factor dest factor not equals self dot blend. We're going to do this thing. Where do you live? this one, GL blend func. We're just going to do that, and self.blend equals source factor, dust factor. And then this, instead of calling a blend func, it calls self.context.blend. And we need an unsafe. All right, and now we should be able to render it and see the scene is the same. If I messed this up, it should actually be fairly easy to tell because the terrible way that I'm doing my lights right now depends on blending. Even though I've only got one light in the scene, to do ambient and then a light, I render once without the light to do the ambient color, and then I render once with the light without the ambient color and blend that in just to get the diffuse and specular highlights. So actually, now that I say that, it occurs to me that this isn't rendering 16 meshes, it's rendering 32, because it's rendering each one twice, once without the light and once with the light. So probably one of the biggest advantages I can do in order to improve performance that I should take a look at in here. Because right now the way I'm doing it is like, first I'm minimizing OpenGL state changes. That's not really going to be big wins, but it's a kind of architectural change within my OpenGL library that I want to do anyway, so I'm just getting it out of the way. Same thing goes for this one. Then I was going to work on batching, so I got to add a note for that. Batch draws of mesh instances with same mesh and same material, shared material. So I want to implement batching so that I can draw all of those 16 meshes in a single go. The other thing that I hadn't thought of, but is definitely contributing to the slowness, is actually I think I already have a ticket in here for it, but it should be draw multiple lights in one draw call, which I think should implicitly have the idea that currently I'm drawing, it's taking 2 draw calls to draw 1 light. It's not even that, I use 2 draw calls to draw 2 lights. It's actually 3 draw calls to use 2 lights. The downside is drawing, I say it right here, the downside is that drawing n lights requires n plus 1 draw calls, which is completely non-viable under a reasonable workload. Apparently, it's non-viable even under a very trivial workload. 16 meshes, and it's already not even running at 30 frames a second. Which is just terrible. Just embarrassing. Don't mind me just chatting on the Facebooks. Okay, so that is the bulk of the easy stuff. I suppose we can take a look at these times, but we're not expecting to see a change, and they fluctuate so wildly that even if it were different, I'd have to do some statistical analysis on it to even know that they're different. So I've done, at this point, the easiest changes. Now that these are no longer unsafe, I can hoist them out of the unsafe block. These are the easiest ones. These don't require any real tracking. It's kind of like to show you the difference between what these are and what the why the uniforms are going to be difficult. You can kind of think of the server capabilities as being similar to the uniforms, where the server capabilities are all calling the same function. They all call GL enable, and then you pass it in a value specifying which functionality you want to enable. But since I know ahead of time all of the server capabilities that are supported, I can just make a variable for each one of these rather than, say, sticking in. See, I could instead do enabled, or enabled server capabilities, hash map, server capability bool I could do that. And then instead of having all of these, I just have the one, and I'd stuff them all in the hash map, and every time I changed it, I'd have to do a hash map lookup. That's potentially not terrible, but since I know ahead of time exactly what all the server capabilities are, there's kind of no point to doing that hash map lookup, to incurring the extra overhead of the, sticking everything on the heap, doing the hash lookup, comparing those values. Potentially, the hash map's gonna, every time you do a lookup, it's gonna be unsure if that value's in there, but I'm probably gonna stuff every single value in at the beginning, so I know at compile time what values are needed. So really, this kind of saner way of doing it is just making them all struct members, because now both I and the compiler know what all these values are, and it can kind of track them and optimize them more efficiently. The problem with setting uniforms is that there can be an arbitrary number of uniforms holding an arbitrary number, like kind of arbitrary values, although it's not fully arbitrary, but it's, it could be any one of these plus, all of the other ones that I haven't supported yet, but these are the ones that I've added so far, and this kind of gives you a rough idea. It's, a chunk of a whole variety of numeric values, matrix values, texture values, potentially other stuff. And there could be a bunch of them, and it actually varies. Oops, here we go. It actually varies program to program, but shader to shader. Your shaders declare your uniforms. I can actually show you an example of what my shaders look like for my renderer, calling them materials. So my textured diffuse lit shader, let me make this GLSL just for better syntax highlighting. I declare uniforms as properties. So every material can have properties such as colors, floating point values, textures that can get slotted in at runtime. And on top of these, the renderer also injects a number of properties in, such as light position, the transform for your matrix, so you can move it around in space. Hello, Slints, in your strange chat spam. Thanks for coming to watch. So what was I saying? Yeah, so there's a ton of uniforms. They aren't necessarily known at compile time. They can't necessarily be known at compile time, because you can load materials up at runtime. So that poses an interesting question of, how do I minimize changes to the uniforms? That is potentially one of the things that I really want to pay attention to, because uniform changes are potentially expensive, and there's going to be potentially a lot of them. So if possible, if I know that, or if I can determine that the renderer is trying to set the same uniform value for every draw, for every mesh, every frame, and it's always the same value, it would be nice if I could detect that uniform is not changing, and then just completely elide the OpenGL call. The problem with that, for handling that at this low a level, is that without somehow knowing in advance what all of those uniform values are, I have to fall back to stashing it in a hash map, or any kind of map. But so I could do something like uniforms hash map, and then it would be like a string value. They're not called strings in Rust. I'm fucking a Rust developer, and I'm getting it wrong. Too used to doing C# development. Ref static strings. That's actually probably not even right, so I probably do want strings. So probably hash map string like uniform value. Yeah, there you go. So it'd probably be something like that, which is not ideal. I mean, already it's not ideal. The fact that that my OpenGL library is having to do these heap allocations. It has to, stash stuff in hash maps. Let me think of it this way. The renderer is probably already doing effectively this exact same thing. The renderer is keeping track of all of the uniforms in the current shader, with a hash map. You know, that's kind of the whole reason why I have this material system in the first place. That's the wrong one. Is that way I can declare, instead of, you know, having to parse a GLSL, I can declare my shaders as properties in a kind of in a format that I know that is what the renderer can support, and then the renderer can know what uniforms have to be in the shader. If the OpenGL library has to track those exact same uniforms, you know, if the OpenGL library is sticking these in a hash map, the renderer is probably also sticking them in a hash map. It's probably the exact same values, doing the exact same thing. And then you also, on top of that, have the problem of removing uniform once they're no longer needed. So let's say the first draw call sets uniforms foo and bar, and then the second draw call only wants foo set. The OpenGL library potentially now has to like diff the two sets of uniforms for the draws, update any ones that have changed, and then clear any ones that haven't changed. Maybe. It's possible that we don't care about clearing ones that haven't changed. Like maybe if the draw isn't setting a uniform value, it's because the shader doesn't have that uniform value. In which case, clearing the old value for that uniform doesn't matter because it's not going to be used. But it's also possible that the shader is using that uniform value and it's expecting it to be whatever the default is, which is why it's not setting it. And if it still has the old value, that's going to break the shader. So probably the more robust way of doing things is the OpenGL library would have to clear out any undeclared shaders. But then that brings up the problem of, okay, now I've got to keep a hash map to track the shaders. I've got to do a bunch of work to diff the old set of uniforms with the new set of uniforms. And as I'm going through this, because I don't have a solution to this off the top of my head. I'm kind of thinking about this as I talk now. And as I talk about it, it seems to me that I don't really want this to be a responsibility of the OpenGL library. Which kind of brings up some other questions, but at least says, this is something that I expect the renderer to already be tracking. Just let the renderer track it. Let the renderer be in charge of only changing uniforms that have changed, and don't set uniforms that haven't been set. So then the only problem with that, or the only thing that I need to then take into account, is clearing uniforms once they're no longer used. So the way that this is set up now is, let's take a look. You specify in the draw builder here it is. It was right there. I scrolled right past it. You specify in the draw builder the name of the uniform and the value, where the value is anything that's a valid uniform value. And we basically verify that it's a valid uniform for the shader, which is actually less than ideal, because this is some extra checking that the OpenGL library is doing now, that the renderer, I know my renderer is also doing this. So to this checking is bad, or maybe not. I don't remember. We want to get rid of this. Let's go back. There we go. So, we're verifying that the uniform location works, and it's actually just silently ignoring if you try to set a uniform that isn't in the shader. So that's an interesting one. This also poses kind of the similar problem. We basically fetch the location of the uniform every draw call, except the locations for the uniforms won't change within a program unless the program is recompiled. So what I maybe should also be doing is I have down here, let's do, that's wrong. Fold 2. There we go. That makes things a little bit more compact. So program, my program object abstraction, keeps track of the OpenGL program object, but maybe it should also be caching off uniform locations. Uniform location. That should be like hash map string uniform location. So perhaps instead, so what I'm doing here is, program.get uniform location, whatever. Every time I call get uniform location, this is doing an OpenGL call, which is exactly the kind of thing I'm trying to minimize. So if I try to get the same uniform location 10 times, it's going to make 10 OpenGL calls, even though that can never change. So probably what I want to be doing is I want to be caching off these uniform locations. Then the first time you try to get the uniform, it gets it, caches it off, and then every subsequent attempt, it doesn't have to make any OpenGL calls. But that brings back in the problem of, like, okay, now the OpenGL library, since we can't know at compile time how many uniforms there are, we need dynamic allocation, which means now for every program that you create in the OpenGL library, we're going to have a dynamically allocated hash map that can potentially regrow and reallocate as you grab more uniform locations. Like, it doesn't know in advance how much space to allocate because it doesn't know how many uniforms are in this particular program. And that's all stuff that the rendering library at a higher level probably knows. When it creates the shader, it probably knows all of the possible properties that it can have, because actually I know definitively that the renderer does know how many properties it can have, because if we take a look at this right here, this grody bit of nonsense, we can actually see all of the uniforms that it injects into the GLSL shader. So it's got all of these. These are all the built-in uniforms. Plus, if we can see exactly where it is, for property and source properties, it also injects one for every property declared in the material file. So we know exactly how many uniform slots we need, and we even, like, all of these, we know the names of them at compile time. So we wouldn't even, in theory, all of these wouldn't even need to be stuck in a hash map. These could be done in a struct and be known at compile time. And we know that all of the built-in ones are also set pretty much every frame. So it brings up all of this rambling kind of summarizes to the question of what stuff should be handled in my GL abstraction library, this library, GL util. What should be handled by GL util, and what should GL util kind of not worry about and let the renderer keep track of at a higher level? I think having GL util keep track of context state, most context state, makes sense. What I think is going to be more difficult is stuff like uniforms. And the question is going to come down to, do I want GL util to be caching stuff like uniforms, or do I want it to not give you any help with that? Basically, the renderer is going to have to do all that work and potentially keep track of the OpenGL primitives like the uniform location. Or do I want kind of something in the middle where, let's say, GL util allows you to get a uniform object out of the shader, and then it maybe has some kind of type safety on top of it, or it knows what program it comes from, so you can't use it with the wrong program, but then you only have to retrieve it once and it can be reused in a type safe manner. don't really know for sure what that's going to look like. So what I'm thinking I will do, what I'm thinking I will do is I'm going to not bother with the uniforms right now, since I kind of expect that's not even where most of the performance issues are coming from. So I'm going to leave this, or nope, this is the wrong one. I'm going to leave this where it's applying the uniforms. I'm going to probably say we're going to have to revisit it. So, sorry, I've got an itchy shoulder. It's very distracting. So, sorry, what was I saying? So yeah, I'm going to ignore the uniforms for now. And I'm probably going to work on some smarter optimizations that will actually improve performance. So then the last thing that I got to take a look at before I kind of move away from this is this last little bit of work down here. Down at the bottom, previously I was manually resetting each of these values every frame. So I was just talking about how the idea is I want to change these values as infrequently as possible. Using polygon mode as the example, I only want to change the value of polygon mode if it's changed, and which means ideally if it's only set once and is never, like, it's the same value is always used throughout the lifetime of the renderer. The ideal situation is we only set the polygon mode once, and then we never have to make another GL call for polygon mode. It'll always stay the same. This is very different than what I was doing before, where I would set it once every frame. At the beginning of the frame, I would set it to the value that was specified by the user. And then at the end of the frame, I would reset it to the default value. The idea being, if the user didn't set it the next time they drawed, it would be still at the default value, and they could always count on render. They could always just omit any setting within the draw builder, and it would use the default values. The problem with that is I do way too many OpenGL context changes. Not context changes isn't the right word. I change values within the context too frequently. So I deleted all that chunk of code at the bottom that was resetting those values. The last one that I changed, that I commented out, but I didn't decide if I wanted to delete or not, is resetting the textures. And if we take a look at that, this actually has to do with the way that binding textures to uniforms works in OpenGL. And I think we can see what's going on there with this. So when you create a texture in OpenGL, or let's take a look at a material to kind of see it. So when I do this, property equals texture 2D, in GLSL that gets translated to something like uniform, surface, diffuse. It would be like, I think it's also something like texture 2D. I think it's like texture 2D with a capital D, surface diffuse. So it gets turned into this in OpenGL. When you set that value, when you set the value of this uniform, you aren't actually setting the value as texture. So if we take a look at my texture in here, texture has a texture object. That's when you actually create a texture and then fill it with data in OpenGL, you get a texture object, or maybe you'll hear it referred to as a texture name. But you don't bind that texture name directly to the uniform. What you do is you bind it to an active texture in OpenGL. So texture, set active texture. what is this? I believe that is coming from in here. So if we scroll down, set active texture is just a little helper function because you kind of have to do some junky junk. But basically, you tell OpenGL, I am currently referring to this active texture instead of one of the, there's however many active textures, maybe 30 or 60 or 100. I don't actually know, and I think it depends on your GPU. So you tell it, like, I'm talking about texture number 7, and then texture number 7 is going to be this texture that I want to use. And then instead of telling OpenGL, use this texture, you tell it, use texture number 7, and then it goes and says, okay, you bound this texture data to texture number 7, so that's what I'm going to use when you read from that uniform. And it's all terribly complicated, and I remember it taking me a long time to get it figured out, even though I remember it being kind of embarrassing. Like, I couldn't get these textures working for like a week or something because I didn't understand how this was working. But so then the implication is, if you want to clear the uniform values for all those textures, you actually have to iterate over all of those texture locations, 0 through n for however many of those textures you had active, and then you unbind them instead of resetting the uniform values. So I guess the interesting part of this is that I never reset any of the uniforms, but I did reset the active textures. I think I'm going to just delete this. I can probably cache off those texture values. There you go. I could probably cache off those texture values similar, like what texture is bound to which active texture, similarly to how I would bind any of these other things in the context. So it would be something like active textures is going to be an array of option, texture, object, and then with a length of, I don't know, max texture, max active textures. And this would actually be probably fine. This would probably work pretty well. The one little hiccup is that, max active textures is potentially variable and might be determined at runtime. We can do a little bit of research right now, actually, to just see what that is. OpenGL max textures. How many textures can I bind at once? 32 is the maximum number of textures that can be bound currently, but that was from 2012. You can check, this is what I wanted. You can check the number of texture units available for non-fixed function pipeline rendering with GL get integer v passing max texture image units. So that was interesting. They link to a site with potentially information about the maximum number of texture units. I don't know. I don't want to look through this right now. But yeah, so in order to get this to be correct on actually like a variety of GPUs, this would probably have to be something more like VEC. And then at runtime, at startup, I would look up how many, like the size of this, and just allocate it once to avoid having to reallocate multiple times. This is not as terrible as the hash map thing because it's not going to be growing or changing. It's allocated once on the heap and then never touched again. But I'm not really doing enough with textures right now to really worry too much about it. We are not saving this one. So I'm going to basically just forget about it, and then it's going to cause me problems later, and then I'll fix those problems, which is kind of my MO with this right now because it's all kind of a terrible mess. So, I don't know, let's run our example again and see where it's standing. Should still be super slow, but that's fine. I've introduced a new paradigm to my OpenGL abstraction library, which is going to be helpful in the future as I add more bits of OpenGL context state that could potentially be changed. Going forward with this pattern is going to at least ensure that I'm minimizing the number of OpenGL calls that I can be making. So it still looks about the same. Actually, let me move my camera around a little bit so it's a little bit easier to see what's going on. So example, lots of cubes. I moved it back to, where is it? I moved it back to 50. Let's make it like 35. Like 35. Boy, oh boy, that is just super off-center. I think I messed up real bad when I did some calculations for this. Let me take a look at my math here. So function chord is square size divided by 2. Square size being the length of the sides. So that would be -10 plus times pose. So pose is 0. That should just be at -10. Pose is 4. That should be whatever. Okay, I kind of don't care enough to really think about that right now. So I'm going to commit those changes, and then the next step will be kind of going up a level higher into the renderer, and well, I can decide which exactly I want to work on, because it's going to come down to one of these things. So either fixing my terrible light drawing, kind of figuring out how to do batching, or maybe smartening up the vertex array objects. Smartening up the vertex array objects could actually help a lot with this one, because if you'll notice, a really big chunk of the state change that I'm now making every frame is binding our vertex array objects. And the vertex array object, since I'm rendering the same mesh 16 times, is not ever changing, but I still bind it and unbind it every draw because basically because the way I wrote this was dumb. And I could make that a lot better, and that would reduce I think that would probably reduce a ton of the state change that's going on. So maybe that'll be the next thing I do. I'll give that a shot. So let me commit all of this work. This should all be within GLUtil. Shader, that's fine. This is just moving things around, so now that we're using the context properly, and then the context adds all of this state tracking, and that looks good to me. Oh, this is some refactoring that I haven't really touched yet. And we added a bunch of defaults in here. Okay, so new commit message, reduce context state, reduce GL calls by tracking context state in memory. And I'm just working off of master because I am a scumbag. So yeah, I think the next thing I'm going to want to do is probably this one. I really ought to be smarter about the way that I'm doing my vertex array objects because they're pretty dumb. And completing this one is going to effectively complete this one, at least to the extent that I'm going to bother completing this for the time being. I don't know how I'm going to address uniforms, and without a way of going at that, I'm not going to start on anything right now. So if we take a look at the way that I'm doing my vertex array objects, right now it's built into the draw builder. That's effectively coming from a misunderstanding on my part about the way that vertex array objects work. Meaning effectively like, oh, I thought a vertex array object is associated with this particular draw call. Really, a vertex array object is more like specifying all of the data that's part of a mesh. At least all the data in terms of all the vertex data. So I probably want to hoist vertex array object out of the draw builder. And the way that the draw builder is currently working is when you start a draw, you give it a vertex buffer, and then you can optionally give it an index buffer, and then it'll compose those together into your vertex array object. Probably what I want to do is I want to create a way to just create a vertex array object by giving it a vertex buffer and an index buffer. And then when you create your draw builder, you actually give it the VAO instead of giving it the various buffers. And then when you create a mesh from the renderer side, you create your vertex array object once to represent that mesh, and then every time you draw, you reuse that vertex array object. And that should greatly reduce the number of OpenGL state calls, and it should simplify what I'm doing a bit. So let's just do that. I don't have to make my vertex array object terribly smart right now, because it's not. I don't have to. I think like you can have a number of different arrays in a vertex array object, but right now all I need is a vertex buffer and an index buffer at most. Sometimes I don't even need an index buffer. So I'm going to try to make this semi-smart. We're going to do pub struct vertex array object. We're going to do, I feel like that's kind of dumb, right? Vertex array. And we're going to do vertex array name, just exactly what the draw builder is doing. But we're also going to give it the vertex buffer? Vertex buffer? Maybe? And we also want the index buffer, which is going to be optional. So the reason why I'm sticking question marks on here is this doesn't actually have to own that data. I can remove these now. So vertex buffer and index buffer is gone. Now instead of vertex array name, we want, whoopsie, vertex array is going to be a vertex array. So yay, that's nice. That's gonna not compile now. So the reason why I got these question marks on here is this object that I'm creating, this struct that I'm writing in Rust that's going to live in memory, doesn't actually own any of this data. All of this data is going to be managed by OpenGL. Like OpenGL is going to create a vertex array name that represents some data in probably the GPU that actually is keeping track of all this data. But I might want to be caching this data in the vertex array object the same way that I'm caching it off in the context. So just like here, I keep track of what the current state of the context is in OpenGL, I probably want to do the same thing for the vertex array. When I create it, I want to keep track of what buffer was set and what index buffer was set because, in theory, the higher level code can change those values. maybe not. I gotta think about what the best way of doing that would be. All right, I thought about what the best way of doing that would be, and I've decided I'm not going to make that changeable. Since I don't have a use case for that currently, the way that, OpenGL has kind of ways of keeping track of when you change the data in a mesh. But I don't have any way, I don't have any cases where I'm testing that. I'm not dynamically creating any meshes or doing like any weird dynamic deformations of meshes. So for now, I'm just going to reflect that directly in my OpenGL library by saying, no, we're not gonna allow you to change your vertex array. If I get to a point where I need to change my vertex array object, I will have to actually figure out what that implies and implement that in a sane way, because I'm not going to be able to implement that in a reasonable way at this point. Also, the fun part is now I've got to move my draw builder no longer needs to implement drop because it doesn't own any data to clear on destruction. But vertex array doesn't need to implement drop because we need to delete our vertex array objects. And so what we want to do, let me think about this. Let me think. I have thought. So we're going to do impl vertex array. We're going to provide a way to create a new one. So pub function new. And that is going to require a vertex buffer. Vertex buffer is going to be a ref vertex buffer. And it's going to spit out a vertex array. All right, so here's where things get here's where things are going to get a wee bit screwy. Or maybe not yet. So all right, things are already getting a little bit screwy because I don't quite know what I'm going to do. So the first thing we do is we create our vertex array object. I suppose what I could do is I could immediately bind the buffer to it. So I could just do this. I can immediately do. I can immediately make the vertex array name active, bind the vertex buffer to it, and then unbind it. So gl bind vertex array, vertex array name null. So we create the vertex array object, immediately tell it what vertex buffer to use, and then unset it. Vertex array name, vertex array name. Better? Less to complain about? We don't have a context. We need a context. Context, ref context. You always need an OpenGL context before you can create any stuff. So, lessons for people. Okay, so this is one way we can do things. This runs a little bit counter to the way that the draw builder has been working so far, where it doesn't bind the OpenGL context. It doesn't bind these buffers until we actually use them. And I think the direction I want to go in is I want to not be just kind of doing OpenGL calls at arbitrary points. I'd like to kind of try to batch up my OpenGL calls as much as possible, and then that way they can kind of be optimized. So the user might say, use this vertex array object, then use this one, then set this buffer, then do this thing, then do that thing, then do that thing, and it might all simplify down to being, oh, set this vertex array object, set this buffer, and then we're done. If I do it this way, where I gotta hide these. This is getting annoying. If I do it this way, where as soon as the user creates the vertex array object, I try to do stuff with it. It may be okay, but it may wind up being unnecessarily expensive. Like in theory, I really don't have to even generate the vertex arrays and bind them until it comes time to draw. Where so like I could lazily create this, so I could make this like option, and then I could make a function that's like function setup. I could do something like, oopsie, I do a function like if, or maybe match self dot vertex array name. All right, let's do if let none. If let none equals self dot vertex array name. If it's not set up, basically if it's not set up, set it up. It's a similar concept to the caching. Like if we have like wait until all the data is in place and then only basically make OpenGL calls for things that have changed. The other big advantage to that I haven't talked about, but falls under the category of making as few OpenGL calls as possible. The context guard. When you use OpenGL, you have to make a context active, because you could potentially have multiple OpenGL contexts. Like you could have, if I have 2 GPUs in my computer, which I do, you could have one context for each GPU and be like doing stuff on 2 GPUs at once. You could have multiple contexts on the same GPU. Like it's just like, if I have 2 programs that are rendering, that are doing like 3D rendering, they are both using the GPU at the same time. You can do the same thing within a single program. You can have one program that makes 2 OpenGL contexts, and because OpenGL is just a big ball of global state, you have to tell it which one is active at any given time. So my context guard is a little utility that I've done to help with that, where, so we should see it at the bottom here. You create a context guard, it makes the context current, and then once it's dropped, once it goes out of scope, it restores whatever context was there before. Usually no context was there before. Using a context guard is helpful for me because I only have to make the context active at the top. I don't have to remember to make it inactive at the bottom, or I don't have to remember to restore the old context at the bottom. But the problem is this is effectively another OpenGL call, and it's potentially an expensive one. I did notice that if I changed my code so that I only effectively called set context once and I didn't set it and then unset it every time, it made things a lot faster. So part of batching up all of my OpenGL calls into like happening in one place, part of the goal there is to reduce the number of times that I have to change the OpenGL context. If I do all my OpenGL calls within DrawBuilder's draw function, like if I only do all of the OpenGL calls within here, I can just set the context once, do all of my OpenGL calls, and then unset it at the end of draw, and then basically never do any more OpenGL calls until the end. Potentially, that's also got downsides. Like in theory, I could do something like call like gen vertex arrays, and then OpenGL kind of does some work asynchronously in the background. Like it gives you the new vertex array name right away, but in the background it might be doing like allocations within the GPU memory and that sort of thing. And if you maybe like gen the vertex arrays first, wait some amount of time, and then actually try to draw, that work might have already completed. Whereas if you try to do all of the work all at once within the draw function, it might back up and slow down the GPU. I don't know. I'm really at the edge of my experience here. This is all kind of new stuff for me. So I'm going to kind of go with the easiest version of this first, and then as I run into problems, I will try to correct it. And so that's going to start here with, this is not an option. Now we're going to do context is going to be GL context. This also needs to keep track of its context, so it can use a context guard. So self.context context.inner. Okay, so now I have my vertex array object basically working, or at least I can create it with just a vertex buffer. But I also want potentially an index buffer. So I'm going to do pub function new, not new, pub function index buffer, and we're going to do ref. Probably let's do ref mute self for simplicity's sake. And then we're going to do index buffer is going to be a ref index buffer. Another thing that I haven't addressed yet that I should, but is also kind of just like a problem that I haven't solved in general. There's no lifetimes here connecting the data that's owned by that's like being borrowed by the vertex array and the data that it's borrowing. So for example, we create the vertex array with the data of the vertex buffer. But it's possible that you can say create a vertex array with a vertex buffer and then destroy the vertex buffer, and now the vertex array is going to be in a weird state. I think OpenGL says that it gets disconnected from the vertex array object once the vertex buffer is destroyed. But that's not reflected in our code. The way that this is set up currently, you could accidentally destroy the vertex buffer without realizing it and think your vertex array is still set up correctly, and now it's not, and now things are kind of weird. So I'm going to want to do something to hook those two together, hook it up in some way where like the vertex array object can't outlive the vertex buffer object, or at least can't outlive its data. But doing it the default way where it says like using Rust's super cool lifetime system, setting it up where the vertex array object actually can't outlive the vertex array object, or the compiler will yell at you, I think is going to cause more ergonomic problems, because there's a potential that I want to stick both the vertex buffer object and the vertex array that owns it, or that's borrowing it, inside the same struct or inside the same collection, and Rust basically can't see that. It turns into a runtime thing. Like you could at runtime pull the vertex buffer out and destroy it, and Rust can't verify that at compile time, so it doesn't want to let you. So I'm going to actually have to do something similar. I have to use some kind of like runtime checking to verify that your vertex array object, or your vertex buffer object, your vertex array object doesn't outlive the buffers that it's using. Really, actually, I think I have a real simple solution to that. Vertex. There we go. I got words in me. Vertex buffer is going to be a vertex buffer, and index buffer is an optional index buffer. And there we go. That's our vertex buffer, index buffer, none. So instead of borrowing the vertex buffer that it's using, it's now just going to own the data. And it'll just work because I say so. Am I drunk? I am drunk. I'm missing a letter. So that actually resolves the lifetime issues. It brings up another issue of what if I want multiple vertex arrays to use the same vertex buffer? And the answer that I have for that is I don't ever do that right now, so I don't really care. And I'll have to come up with a better solution when I actually start to care about that. Well, so the nice part is I can just do this. Self.index buffer equals sum index buffer. Hooray. And the one little thing that I want to do in there is I want to set, I actually have to set up the data as well. So we want to bind the array object, self. Then we want to unbind it at the end so that nobody else gets scronked over. We actually want to... Alright, here's another problem that I've got to address. Well, I'll say what it is in a second, but to do cache bound VAO in context. So I've got a problem here. I will to do cache bound VAO in context. And I will perhaps solve this in a second. You know what? I'm just gonna get rid of this problem entirely. Pub function with index buffer context ref context, and we actually want to do ref mute context because we do need to change the context state, so we want a mutable reference to the context, and then we want vertex buffer, and index buffer. That's going to return a vertex array. And we're basically going to do the exact same thing we did here, but we're also going to tack on an index buffer. Some index buffer. So we bind the array buffer, but we're also going to bind the, this should be right here, the element array? Yeah, our index buffer. OpenGL's got some interesting names for things. I can't tell if, oftentimes I can't tell if it's just the names are dumb or I am bad at, I don't understand OpenGL, I'm like misunderstanding it and then I'm doing things wrong. Oopsie. Index buffer dot buffer name. See if that quite works right. This site's not complaining about anything around here. And so this we can actually handle right now. We've got our vertex array name. So our context, just like it's got a bunch of stuff, we're going to do bound vertex array. It's going to be an optional vertex array name. And then we're going to need a function that says create function bind vertex array ref mute self vertex array name. Then we'll do if some vertex array not equals self dot bound vertex array. We just do the thing. We do the thing that I was doing over here. We bind it. Let's make this vertex array name self dot bound vertex array equals some vertex array name. And then we never have to worry about unbinding because it'll either keep it the same if you're trying to bound the vertex array that's already bound, or it'll change to the vertex array that you want bound. And I never try to, I think it's possible to do drawing in OpenGL without a vertex array object, but I never try to do that, and so I'm not going to run into any problems with it because I don't care. So we're going to do context dot bind vertex array name. We're going to do the exact same thing here. And now we no longer need that comment. So the bit of trouble that I kind of mentioned offhand earlier was here. When we delete the vertex array object, it's actually going to clear this. So we want to do something like context dot bound vertex array equals none, which really means like calling a function on it that does that. So we want like context dot unbind vertex, or sorry, I said we want it to be context dot bound vertex array equals none, but it's really we want if some self dot vertex array name equals context dot bound vertex array. So if this array name is currently bound when it gets destroyed, it gets unbound automatically by OpenGL. And so we want to make sure that when we delete our vertex array object, that gets reflected properly. Problem is, we don't actually have access to the full OpenGL context. We only have access to the raw OpenGL context in here. And if I were to try to change it to something like ref mute context, that actually makes things way more complicated, because now we need a lifetime attached to it, which means I need a lifetime on the object. And that means that the vertex array object can now no longer outlive the context, which is, I mean, that is technically correct, but it provides a bunch of, or it poses a bunch of usability problems because it makes things a bit difficult. So this is actually going to be a problem. This is a problem that I thought about earlier because we basically have the same thing with all of these bits of state. I mean, not so much the vertex buffer, but for example, the textures. Texture 2D gets dropped as well. But remember, I was talking about those active textures earlier. If the texture 2D is one of the active textures and it goes out of scope and gets deleted, it gets automatically, that active texture gets unbound. So we want to track that within our context, but we don't actually have a way of getting at the context currently. The solution, I think, to this is probably just going to be, is just like really straightforward and dumb, although it's going to require a bit of refactoring. It probably means we just want to do, instead of ref mute context, we probably just want rc ref cell context. We probably just want to make our context shared. And then any object, instead of having the raw OpenGL context, nobody gets the raw OpenGL context. You go through the shared context, and then you can either get a mutable borrow on it or a shared borrow on it, and such and such and such and such and such. The problem with this one is it basically means I've got to completely refactor the way the context is being used. Or perhaps not. Let's do this, context inner. Name RC is not in scope. Of course it's not in scope. Who would put it in scope? That's crazy. So we need, where's RC live? I think it's just an RC. So we want use standard RC, use standard cell, ref cell. And then I made it something, I said context inner. That's not a thing that exists because the context is holds all of its data. Well, I want to add it now. So I want to do pub struct context inner. And I want the context inner to actually have all of this data because it's this thing that's actually going to be shared by everybody. And then context in turn is probably just going to be a handle that gets given out to the owner, or gets given out to user code when they create the OpenGL context. So while I want to do something like RC, ref cell, context inner. And so this will keep the public interface the same. Oh, geez. This is now going to be raw, and this is going to give me a bunch of type errors. So this keeps the public interface the same. Any code that was using the context before will continue to use it the same way, but now stuff within the anything within this GLUtil crate can get at the context inner and get its own handle to it, and now it'll be able to modify any of the state. So I'm going to hit save, and then I'm going to basically fix all of these compile errors because this is going to be a wee bit of a mess. So again, we don't have ref cell or RC in scope, so we need use standard RC and use standard cell ref cell. Context inner is not debug. Well, of course it's not. All right, so now what are we seeing? Look at all this. Look at all this stuff that's terrible. So I want to do let inner equals context. Well, let's do RC new ref cell new. So the contents of context inner. So what I'm doing here is let's make this raw instead of inner. I'm giving the context inner the raw OpenGL context, and then I'm giving the context itself it as well, just for simplicity. This value is going to be the same between the two of them, but some people are only going to have access to the context inner. Some people are going to be actually using the raw context itself. And so just to avoid, every time you want the raw context to access or every time you want the context object to access the raw context, I don't want to have to borrow the inner ref cell. So I'm duplicating this data for some simplicity. So Juan Momo is asking if I could show my game. That's a good question. I don't really have much of a game, but being able to demo what I do have would be a good idea. So let's see. I can probably stash all of the changes. So let's do git status, git stash, git status. Nothing should be changed. So let's go up. Cargo build. Let's see if this will actually compile in the state that it's in. I'm hoping that it will. Crap. All right, hold on. cd gunship rs git stash pop. So how do we stash specific files? Can I do that in here? Let's do git stash h. Let's see if there's a way to stash specific files, because I just want to stash the ones that are going to be broken. So git stash specific files. How can I git stash a specific file? You can do git stash patch. You'll enter an interactive mode where you're given each hunk. Ugh. I don't want to do it hunk by hunk. I want to do allow you to stash all unstaged changes. So I can do this. Git add dash I. Now I can do U, and I can add everything that I don't want to stash, which would be, say, 1, probably 4, 5, 6, 7, 8, 9. So I just want to stash the 2 things within GL util that I just changed that are going to break everything. So let's do q git status, and now if we do git stash, what was that command? Where are you? Oh my god, I'm so bad at this. Git stash keep index is what I want. Git stash keep index, git status. All right, so now let's do git or cargo build, and we'll see if that will actually build this time. Looks like it is. Yeah, okay. All right, yeah, so that's building, so let's run it. All right, so here's my game. Oh my god. Hold on, let me disable that debug spew, because that is actually slowing things down a whole bunch. Or what happens if I just compile it in release mode? Will that do enough? That might actually take longer than just disabling the debug spew. That would be funny. This is my super favorite part of Rust development, is the terrific compile times. This is technically a release build, so you expect release builds to be a bit slower, but it's pretty much the same way on debug builds as well. I need background music for when I'm compiling, since it often takes a little while, especially if I'm compiling top level crates. Wow, that is not better. All right, source engine. All right, let's just disable that debug spew. So that is stopwatch new. Let's just comment that out. All right, there we go, and it's running actually fairly smoothly now. So this is the little bit of demo that I've got working for my game so far. What is that little dot that is next to my gun? I don't know. But so it's a first-person shooter, or will be. You got a gun, but if you click on the shooty buttons, nothing's shooting. Isn't that crazy? If you hit R, it loads in a single bullet. If I scroll the mouse wheel, it this is supposed to be a revolver, so it rotates the cylinder. So I can rotate the cylinder, load in a bunch of bullets, and then if I right mouse button, it pulls back the hammer, which also rotates the cylinder. Left mouse button fires. So right mouse button pulls the hammer, rotates the cylinder. And I can do that a bunch of times to shoot. And then once I'm out of bullets, once all my cylinders are empty, you can kind of see that once they're empty, they become really small. So the one at the top right now is empty. The one to the right, or to the left, the one that's now at the top, actually has a bullet in it. So if I click, it should shoot. And now all of my cylinders are empty, or all of my cartridges are empty, and I can't shoot anymore. And I can't unload the gun yet, and I also can't destroy objects in the world. And you can already see just from like shooting a handful of bullets, it's slowed down substantially, which is why I am not working on the game. I am working on the engine instead. So Juan Momo is asking, what are the benefits of using Rust for your game? The benefits are, I like Rust. I mean, the benefits are Rust has a performance profile equivalent to C or C++ in that it runs really fast. It's really low level. Like you have direct access to the memory. You're running straight on the CPU. There's no runtime or anything. But it's a much more modern language than C++ is. When I was learning game development in school, I learned C++, and my first job doing game development was in C++. And I didn't hate it at the time, but pretty much as soon as I started learning Rust and started seeing like, hey, I can get really high performance without sacrificing usability, like without making programming being like, hammering nails into my fingers the way that C++ is. I kind of went in that direction. So right now, Rust as a game development language is a bit unproven. There's a whole small community of people doing it. There's an IRC channel for it, Rust Game Dev, where there's a whole handful of people who just chat about this stuff all day long. So I'm certainly not the only one who's trying to do this, and I'm far from the most successful person trying to do this. I'm almost doing this more as a learning exercise than an actual practical game development stuff. But personally, I have really high hopes for Rust as a game development language. I think it kind of ticks all the boxes of things that you would want from a programming language being used for game development, and that it is fast, it is ergonomic, it like doesn't crash a ton the way that you might experience when you're doing like C or C++ development. Like you use a pointer wrong and you've crashed the whole program. Rust kind of fixes all those problems without sacrificing any compile time stuff, or without sacrificing any runtime performance. So it's personally my most favoritist language in the world, and I would like to see it succeed as a language for game development. Hope that answers your questions. Also, thanks for coming by the stream. Hopefully there's something interesting going on every so often. So I'm going to go back to doing what I was doing previously. Git stash pop. So git status, git reset, git status. All right. Cool. So that brings me back to what was going on in here. Sticking my context within a ref cell. And we're going to do inner, raw, and bound vertex array. Bound vertex array is missing. It is. So bound vertex array should be none. Bound vertex array should be none by default. No vertex array is bound. All right, let's go through all these squigglies one by one, deal with them. So instead of self.inner, this is all going to turn into self.raw, because I renamed things. All right, that does bring up a problem right here, where I've got this inner function that was returning the raw OpenGL context, and now I've got another thing that's called inner, that's the actual inner object. That's going to be a little bit annoying. And then here's where the other bit of fun stuff happens is all of these bits of caching off data within the context that I was doing earlier in the stream. This is now no longer being done on the actual context object. This has to happen on the context inner object. So I think what I'm going to do is, rather than trying to modify all of these functions, I am going to do this. Impl context inner. And now they all exist on the context inner. How exciting is that? And look at how all of those things compile now. We're going to move this. Well, probably what I'll do is, instead of moving all that stuff up, I'm going to move this stuff down. There we go. And self.raw, make current, destroy context. And that takes care of the context. So the context is now up to date. The problem is all of the other things that now are broken. So ref cell context inner is not defined. Context star index buffer. Darn you and your ambiguities. Oh wait, hold on. Oh, what? Oh, that's awesome. Okay, so this may not be, if you're not familiar with Rust, this is actually a big improvement over the way things used to be. So previously, once upon a time in Rustland, I think I'm opting into this. I think this is unstable, but I never really noticed this before. But so previously, if you just did like import star, just import everything from 2 namespaces in Rust, it would give you, like, the imports would fail. I would have gotten, both of these are importing something named context, and so I would get like red squigglies under the second one because it says, hey, context has already been imported, which is not really an ideal way of going about it. It's really annoying. In C#, what would happen is if you like do using and pull in 2 things with conflicting names, when you tried to use that name, it would say, hey, you've got 2 different things with the same name in this namespace. It's unclear what you want. Specify exactly which one you want. And now it looks like Rust is doing that. Now you have to, if you have 2 things with the same name, you can specify exactly what you want. So, but it's also a little bit smarter than that, because if you say like, hey, this one's importing everything, but this one I'm explicitly importing context, it knows that when you're using context, you mean this one because you explicitly imported it. So if I do it like this, it'll know what, when I explicitly say context, it'll know what I mean. And that's awesome. That's I don't think that's in mainline Rust yet, but that's a real nice improvement over the way things used to behave. I'm happy to see that. All right, so now all of these are going to break. All these places where I'm calling like context.bind vertex array, or in here context.whatever, context.whatever, context.whatever. Those are all broken now, because I have to actually get access to the contents of this ref cell. So something I'm going to have to break as well, sadly, is let's do context.inner. Let's find all occurrences of this, and I think I want to just replace this with context.raw. GLUtil, yeah, perfect. So I want to replace this with context.raw. Which now more accurately reflects what is going on. So this function is now going to be raw. It's going to return the raw context. And we're going to get a new function, pub create inner, which returns a handle to the ref cell. So, or not the ref cell, to the RC. So RC ref cell context inner. And I might want to rename context inner to something like context cache, context state cache or something, because that might more accurately reflect what it's for. Also, I think I'm going to have to end the stream in just a few minutes, because I'm actually going out in a bit. I was not paying attention to the clock. So I'm going to quickly see, I'm going to give myself like 15 minutes to wrap this up. If there are any questions or comments or anything, ask them now before I go offline. Otherwise, I'm going to wrap this up as much as I can and then head offline. I'll finish this up another time. Alright, so let's just go down the line of all these. Oh god, so many issues. Can I... Oh, shit! Oh, I didn't think I could do that. Okay, that's actually... That's much better than having it like just take up half of the screen. So I only wanted to show like 5, and then I can just scroll through the rest of them. So, unresolved thing, vertex array name. We don't care about vertex array name, we don't care about vertex buffer, we don't care about the index buffer. We just want vertex array, vertex array. And so that instead of passing in a reference to the vertex buffer, we want vertex array and vertex array. Right? Is that right? And I want to check to make sure that you don't pass things in from the wrong context, but I gotta just slap a to-do on that. I'm not going to bother with that now. Make sure vertex array comes from the right context. All right. So next up, vertex array new, context.bind buffer, or context.bind vertex array, context.raw. We don't want that. We want context.inner. My expectation is that a lot of the so I changed all the places that were calling context.inner to call context.raw, and I'm expecting actually I probably want a bunch of those places to be calling context.inner instead. So I'll have to muck about with that. So let's do let context inner equal context.inner. It also occurs to me that I should probably do something like context.guard or something. Like that would make all of this code so much simpler. I'm not going to bother with that just a second though, because I kind of don't care a ton. I think I had like a reason to make it not a function of the context, but whatever. So what I really want to do is let mute context equals context inner dot borrow mute, and I'm gonna have to be doing this all over the frickin' place, but it makes my code not wrong, so that's what I kind of want. Oh, and here's the fun part. Previously, context inner was, or create. Previously, since this was all part of context, I had to make all of those things private, or I had to make all this stuff like pub crate. I can probably just make this stuff pub, and since the type is private to the crate, that might just work. Again, I'm kind of doing stuff that's not really relevant, so I don't know why I'm bothering. I'm easily distracted. Pub crate function raw ref self GL context. I should probably type def GL context to be like raw context or something. Self dot raw. So now this will work. With index buffers, got to do the exact same thing. Context dot inner, except we don't want to do that. We actually want to do just context inner. Since we already got it, we don't want to have to clone it again, since that would be unnecessary. Although it doesn't really cost all that much, but you know, why do it? Why do something costly at all if you don't have to? And so now here's where we fix the problem that started me on this whole nasty refactor business that I'm doing. We want to do something like this. Like context equals self.context.borrowMute. And then rather than doing GL delete vertex arrays, we want to do something like, or we want to do GL delete vertex arrays, but then we want to do like context.clear vertex array, or unbind vertex. Here we go. Context.unbind vertex array, and we want to do self.vertex array name. So that should be not a real function, right? Self.context. Context.raw. And then, so we've got bind vertex array, and then we want another one that's function unbind vertex array, refmute self, vertex array name, and we want if some vertex array name equals self dot bound vertex array. So basically, if the vertex array object that's getting destroyed is currently bound, we want to unbind it. GL bind vertex array name null, and we do self dot bound vertex array equals none. But if either no vertex array was bound or some other vertex array was bound, we don't want to change it. So yeah, that's now doing what we wanted to do. This needs an unsafe if some vertex array name. So now we have so all of that work, we've got a vertex array type that's kind of doing exactly what I want, but we kind of have to fix all of this junk too. This one is actually fortunately pretty straightforward to fix. So we can just do let context equal self.context.borrowMute, borrow the contents of the ref cell, and then all these times we do self.context.whatever can just be changed to context.whatever, and those should all work now. I don't believe this is correct. This is currently ref context, and we want this to be a RC ref cell context inner. But yep, so we'll see that all of these are fixed. We're down to 17 errors, but new is going to be fucked up. This has got to be context.inner. And that's slightly jank. Self.context.raw. Borrow. Self.index buffer. Oh, wait, actually, we don't care about index buffer at all because that is now controlled by the vertex array object. Self.context.borrow.raw. That works. Down to 13 errors. So here's a little bit of nastiness as well. Basically, since I wasn't doing the vertex array object correctly before, the entire way that I was handling vertex attributes was wrong. This mapping a trib location, mapping a trib name is kind of some dumb nonsense that I was doing with hooking up shader inputs to vertex array names. I basically have to just rethink the way that I'm doing this. But I am kind of wrapping up the stream, so I don't know. I'll do it offline. So thanks for watching. Thanks for coming out. I know that it's not always the most interesting stuff, but I kind of don't have anything better to do on weekends, so I'm going to keep streaming anyway. Thoughts to wrap it up. So far, been working on this rendering optimization stuff for a couple of days, and I've made basically no improvements to performance, which is super reassuring. But these changes that I'm making now should be the last bit of kind of low-level OpenGL stuff that'll get rid of some blockers that will then allow me to actually improve performance. Next time I come online, I will hopefully have just kind of finished up with this work, and I will be able to next work on the actual renderer and make the renderer kind of be smart and less dumb, because right now it's very dumb, and that's probably where a lot of my performance problems come from. So thanks again for coming out. I hope to see you all again sometime soon. Enjoy your winter time. Bye-bye.